Okay, so hello everybody. I'm going to present our paper, which is titled Supervised and Unsupervised Evaluation of Synthetic Code Switching. So first, let's talk about the motivation of our paper. The main topic is code switching, which is a phenomenon of mixing words from different languages within one sentence. Recently, we have seen a growing number of CS code switching or CS speakers in the world. We have seen that particularly in social media. And as a result, there has been a rising interest in solving NLP tasks for CS data. It has also been shown that fine-tuning on high-quality CS data is beneficial for the solving quality of those tasks. As big datasets of real code switching sentences aren't readily available, there has been work of developing synthetic CS datasets. And as a result, the task of evaluation of those synthetic code switching datasets is emerging. So in our paper, we approach this task in two setups, supervised and unsupervised. One of the contributions of the paper is that we achieve a state-of-the-art result in a competition for supervised synthetic CS evaluation. And we also find that models fine-tuned on CS data continuously outperform their original versions. So the research area close to our work are methods for generating synthetic CS. Further, these are models that were trained on CS data and for CS data. And finally, the concept of acceptability measures that we use in our paper. It was presented in the work by Lau and others. And this is a method of unsupervised linguistic acceptability prediction. The method is it consists of computing modal perplexity changed in some way to normalize for text length and other things. So let's talk about the data that we use in our paper. These are hinglish data. Hinglish is a code switching variant of English and Hindi. And first, importantly, we use the Hinge dataset. Hinge dataset is a dataset of both real and synthetic Hinglish sentences with quality ratings attached to them. Further on, the authors organized the Hinglish Eval competition based on that dataset. And secondly, we use the dataset that we refer to as TCS, and it is a collection of 750 synthetic Hinglish sentences, also with quality ratings. And it is worth mentioning that Hinge is relatively bigger because it has 4,000 samples in it. Let's talk about the experimental setup that we build in our paper. We experiment with a line of transformer models, both English and multilingual, and their versions trained on CS Hinglish data by Nayak and Joshi, and they were trained on a very big corpus of real Hinglish sentences. And as I said, two setups, supervised and unsupervised. So let's proceed to the results. First, the unsupervised results for TCS dataset. Here, expectedly, models trained on Hinglish data outperform their original versions. It is also interesting that originally TCS dataset was written in Devanagari script, and we also create a transliterated version of it. And models that have seen Devanagari Hindi during their pre-training, which are GPT, MGPT, and MBird, they perform quite well, which doesn't happen on transliterated version of the dataset. Further, unsupervised result for Hinge. Here, the Hinglish models also outperform their original versions, and here we can see that we use 3 acceptability measures, and our results go in line with the original work about acceptability measures because PenLP acceptability measure performs the best on average. Yeah, now for supervised results on Hinge. Here we can see original 10-class classification, and here MBERT trained on hinglish data wins on the test part of the dataset, and it establishes new state-of-the-art, obviously overpassing the baseline presented by the organizers. We also create a regression version of this task, and it allows us to see a growth in MSE scores, but doesn't lead to the growth of F1 scores. We also create a binary classification version of the task, and it expectedly allows us to increase the F scores by a large margin. We also perform an error analysis and find that the model, the best performing model, tends to make mistakes on complex sentences, which are longer, which have more Hindi, and which have a bigger number of code switching switch points in them. So yeah, now for the conclusions, we address the task in two setups. We achieve SOTA for supervised quality prediction, and we find that CS models outperform their original versions. What can we do in the future? We can directly compare unsupervised and supervised approaches, and we can continue the error analysis, accounting for popular CS metrics. Thank you for your attention.